In our newest update, we do have the 3D Smile simulation project, which is a new a new project, a new workflow. And with this project, we can analyze the situation of the patient and we can create an ideal design. Ideal design means that the teeth that we design are in the perfect position for our patient. It can be subtractive design, additive design, and it's very important to create such a project for the lab, for everybody involved in the case to be able to analyze the situation of the patient and where the teeth should be. Now, to make it very, very simple, we do have a reference of a smile curve, a gingival curve, and the references that we need with the intraoral scan, as you can see here. So now we do have the option to adjust the ratio, to adjust the buccal corridor, which is always different from patient to patient. And buccal corridor here, that's fine. We have a visual reference. And when we go now to the second step, to the adjustment screen, we have the option to display 4 screens. And 4 screens is very important in our case because we want to see the position of the templates from all perspectives. Using the outlines is very, very powerful. Instead of the full view of the templates, we need to see where the gingival margins are. We need to see the interproximal spaces. We get all the important details that we need to get. So now, that's an ideal design. As you can see here, an ideal design, it means that we started with the width of the centrals, the ideal ratio 100 to 80, and we kept the ideal ratio for all the other teeth based on the centrals. We can also use the match patient calculation, where we now calculate the width of the patient's teeth, and based on this width we fulfill the space in between. But let's start with the ideal because that's what we want to do. As you can see, the patient cannot be now in the perfect ideal design because the ratio of the centrals doesn't match exactly with the width and the width of the laterals and the canines. But nevertheless, we can do some good adjustments here. We do have the group, so we can group all teeth, and now we have the option to reduce, you see, to reduce the width and to make some very, very quick adjustments. We can work with the height, the depth, of course, and then we have the option to rotate. If you want to move the dental midline to the facial midline, we have the option to tilt and to change position. In this view, very important, whatever we do, we see the cross section. And the cross section is important because we need to make sure that our the templates and our teeth and everything, they have the correct axial angulation, and we always can correct and check if everything is fine. For example, let's start with the centrals, right? We want to adjust the centrals, so I see the interproximal spaces in the occlusal view. I see the rotation. I can move, you see, I can move my template as close as possible to the patient's teeth. I have the option to go actually coronal here and fit the gingival margins like even like this, increase the size, right, like this, and now I have a very clean position of my central. considering the gingival margins, considering the axial angulation, considering the ratio, and I have the option to select the central and reflect the size on the other one so that I have my centrals in the perfect position, size, and you see in the frontal view always not the information, all the information that we need, because we see here we need to go with this one more lingual, like this. We use always the transformation tools to move the teeth around. Now, in the cross section I have here in the middle, right? The cross section is always in the middle of the tooth. I have here the perfect gingival margins match. Here it's a little bit different, but I can have the view changed from outlines to full view, right? The 3D templates view, and then we see here what needs to be corrected. I have a little bit of a wrong angulation here, but with my transformation tools I can correct it. We can increase a little bit the width here and reflect on the other side, and here we go. You see now we have an ideal design, ideal position for our centrals. The occlusal curve is perfectly redesigned with the centrals. I see what I can do regarding the position, and we know now because here we have our design tooth closer to the buccal surface of the patient as here. Now we analyze and we see actually that this tooth is in the wrong rotation, angulation than the right central. And so designing, we get very, very deep insights of the issues of the patient. So I'm gonna now just follow, the occlusal curve and the interproximal spaces and design the rest of my teeth. It's very, very easy and very quick because right now seeing every single template from 3-4 perspectives, my smile design can be done very, very easily and very quick. It's the ideal design, so I know that's the way I want to have the teeth in the final stage. After ortho, you see the premolar is very, very rotated, needs to be corrected, and then I make the space here for the rest of my teeth. I see here the incisal edges, so look how easy I designed the right side of the patient. I can put I can change the view, and now I have the ideal design for my patient with all the corrections and all the issues that I want to resolve to get to the perfect smile for my patient. Now I can select and reflect actually the size on the other side so that I get laterals and canines the same width as on the right side. And here with the outlines also very, very convenient. I can correct and rebuild actually the occlusal curve like this. I like it. Interproximal spaces overlapping, I reduce the width, and here we go, very precise next to each other. I have here also the very good view on the incisal edges, as you can see. This view, this outline view, 3D outlines view is very, very helpful, and it helps me speeding up the process of design. And here we see We have the rotation a little bit. And here we go. That's good. Also, using the cross section, it's very, very cool because now we see the position of the crown, the position of our design, and we can here still correct not only the position, but if we want to change the function, if we want to increase the vertical dimension of occlusion, we have here the view in the cross section to do so and to always check if everything is correct. Then we have the outline view, the outline depth. So instead of seeing now the complete form of our teeth, the outline depth shows us actually where the templates go into the gingiva. Very helpful, so that you see now actually the outlines of your new design and not the complete template which is inside the gingiva. Then we have the wireframe, a beautiful view that has no meaning at all, but it's interesting to see a different the teeth in a different way. And we have of course the smile frame, which is for us also a visual reference for the smile curve or occlusal curve. All these views help us creating the ideal design very, very quick. Then we have the 3D light. We can put light and light reflection on our patient. If you have the original intraoral scan with colors, then we have the gingival colors of the patient, and then you can use, of course, the gingival, the OBJ file with the gingival colors, and then you will see also the original color of the gingiva. So the final design looks a little bit more realistic than this STL file, which is now pink, yellow, I don't know what color this is. Good. Then we have the templates. Also, if you want to check the templates, check if the patient needs a different template, a different form, using the outlines, very important, because you see the form of the patient and you see the form of the template. So now if the form of the template is completely different than the form of the patient, you see it immediately and you can adjust. So that's the important thing. This kind of screenshots, this kind of project, this kind of everything you can export, this kind of analysis of the ideal design can be used now in the lab. The way everybody tried, to get the 2D smile design, the outlines, and then use it in the lab. Now you have the real accurate plan using 3D outlines, and you can export all the STL files of the template and the intraoral scan of the patient to import in a different system, and then continue with your project and the treatment plan. Good. I'm gonna save this case. Now, the important detail here is we can now start new projects like simplified mockup, automated 3D design, where we can use the segmentation, the ortho analysis, moving the teeth in the correct position, designing on top. We can use this 3D smile simulation as a starting point for our simplified mockup. So I don't need to start designing from the beginning. I just have the ideal design and I can go to my simplified mockup, which is usually additive, and I can export and print the mockup and put the mockup in the mouth of the patient. That's what we do next, simplified mockup.